So, we're coming to you live from Graphene Week 2025 in Vicenza. And we're going to talk a little bit about two projects within the Graphene Flagship today, ARMS and GRAPHERGIA. And I, Maria Abrahamsson, the director of the Graphene Flagship, have three people from these two projects with me here. Can you please say a few words about who you are?
Hello everyone, my name is Pourkheirollah. I'm coming from Tampere University. I'm technical project manager of ARMS project, so I'm very happy to be here.
So I'm Masouras. I'm the Chief Operating Officer of Pleione Energy, which is a company based in Greece and Germany. We're participating in project GRAPHERGIA, which is focused on the integration of graphene in energy applications. And I'm very happy to be here today and have a fruitful discussion about graphene and energy.
Yeah, and I'm Jinhua from Chalmers, University of Technology, like Maria, but I'm from different department, that is Industrial and Material Science. And within this project, this EU project, ARMS, actually our role is to work with graphene, to coat graphene and carbon fibers. But for myself, I have been working on graphene for many years, more than 10 years. So we work on graphene-related materials, making the composite for very broad applications, from energy, storage, to tribology, to sensors, and also others. And I'm also very happy to be here and to discuss the project and also graphene.
Nice. So we mentioned energy and we mentioned these names, ARMS and GRAPHERGIA, but Tell me a little bit about ARMS contribute to energy and what is the goal of ARMS?
Actually, before starting to talk deeply about Project ARMS, I would like to just using an example tell you what's the difference between batteries and supercapacitors. Supercapacitors are energy storage devices like batteries, but there are some differences between these two energy storage devices. This is just a good example that I have seen in many literatures, and I would like to share it here. Imagine a water jug without any lid. The lid is open, and a galloon with a small lid. Supercapacitors are like these water jugs. They can store less amount of energy, but batteries, they are like galloons. They can store a lot more energy. But looking at the delivery of the energy, you can deliver more energy with water jugs at the same time compared to the galloons. So supercapacitors can deliver more energy at a specific time compared to batteries. This is the big difference between supercapacitors and batteries. And from technical point of view, we are saying that we always say that batteries have high specific power density, high specific capacitance, or high power density, which means that they can deliver higher amount of energy at a specific time. But batteries, on the other hand, they have high energy density. This means that they can store a lot more energy than than supercapacitors. This is the main difference. And in Project ARMS, we are trying to close the gap between supercapacitors and batteries. This means that in our project, our aim is to increase the energy density of supercapacitors. This is the main idea of Project ARMS, and for this, we have some ideas, like using atomic layer deposition to introduce some metal oxide layers, or using some hybrid electrolytes to increase the potential window of the electrolyte. So I'll talk about it in more details. So this is what we are aiming in Project ARMS.
And GRAPHERGIA.
If I can add, so if let's say to make it more simple for the people is, let's say if can try to relate it, let's say with an athlete. So a supercapacitor is the 100-meter athlete. The battery is the marathon runner. So I suppose that we have the same goal, a similar goal to GRAPHERGIA is to make an athlete of the 800 meter, something like that, something in the middle. So yeah, GRAPHERGIA is a project that is mainly focusing on development of actually producing graphene through a sustainable process by using lasers, and also as a resource for this material, biomass, and let's say end-life polymers. So, and then we degrade them in energy applications, such as, for our case, that Pleione is mainly focusing on to integrate graphene into lithium-ion batteries. And also the other sector of the project is to integrate them in textiles for wearable applications, but also for technical textiles, to integrate them into composites. In the first case, in order for wearables, to develop powerless functions for a wearable textile, and on the other side, for technical textiles like composites, to integrate functions like sensing capabilities to composite materials for aerospace applications, or even for automotive applications for this industry. So I suppose that we have the same goal for both projects, is to develop materials in our case in a sustainable way, in order to enhance capabilities, also to enhance the industry in this field, the energy industry in Europe, and to make it less dependent in other sources, and also less dependent to critical raw materials.
So you both mentioned sustainability, and I want to come back to that. But first, maybe Jinhua, maybe you can tell us a little something, because these are European-funded projects, right? So why should our European taxpayers, which includes ourselves, of course, be happy that we are doing this work? Why is this important in a societal context?
Because I think this can solve many issues regarding the energy crisis and also others. For example, the material that we used, if it's not sustainable, definitely after so many years, it will be all consumed. Another thing is that if you don't, while you are producing this material, you don't create more waste or pollutions, that will be the added value, right? So another important thing is that I think this material, graphene, is very unique, and it can be produced from graphite. Graphite actually, we can consider it as not that like a critical thing, but then after you exfoliate it, then it can have a better performance, and then it can make for example, our project within this Graphene Flagship, that is for the supercapacitor, even for the batteries, and it has a much larger surface area, then increase the performance. And I think that's because traditionally, if you use some material, that performance is lower. For example, the surface area is less, and then you need to use more materials. But if you use instead graphene, it has a larger surface area. For example, if you use 1 grams, and then it can equal to 1 kilogram other materials, then you can consume less material. This can be also another added value, I think.
So what you're saying is basically graphene itself is a sustainable material and one that could be sourced sustainable. But then I have to ask, you mentioned hybrid electrolytes previously and said something about metal oxides. And so if we combine graphene with other things, what do we need to take into account when it comes to sustainability there?
Yeah, actually, if I want to tell the whole supercap fabrication of within the project arms from A to Z, we get biomass derived carbon from woods and also from nutshells. We activate this, first we ground this carbon, and then we activate these carbon materials to get very, very high surface area activated carbon powders. And using some activation agents like sodium hydroxide and potassium hydroxide and so on. And then we make inks out of these activation carbon powders using some kind of binders, like ketosone binder, for example. And these inks can be used in printed electronics, and they are conductive, and they can be printed on flexible substrates as well. And after printing these inks, we can get our electrodes ready, and they can be ready for the next phase, which is ALD, atomic layer deposition. And using this ALD technique, we introduce some metal oxide layers like manganese oxide, titanium dioxide for our both positive and negative electrodes. Very, very thin layers of metal oxide, like 5 nanometer scale metal oxides, uniform coating onto the porous structure of the carbon. And then our electrodes are ready, and then we add our electrolyte, for example, aqueous electrolyte like salty water. Very, very like simple and sustainable electrolyte, I would say. And then we add a paper separator between the electrodes, and our supercapacitors are ready, and they can store energy within them. And since we have applied metal oxide layers, their energy density has been increased compared to the commercial supercapacitors. So as you can see, the whole process is sustainable. And because we are using biomass-derived carbon, not like fossil fuel-based carbons, and we are using like aqueous electrolytes. And at the end, after end of life, supercapacitors, I can say that they have very, very long cycle life than batteries. So they can run up to 1 million cycles. It means that they can be charged and discharged up to 1 million cycles with very little decrease in performance after this many number of cycles. And at the end, they can be recycled very easily and simpler than batteries, because we don't use any toxic materials in our devices.
Yeah, maybe I can add regarding this electrolyte. So as Hamad said, it's water-based. You know, water is very safe. But if we compare the supercapacitor that we made as compared with the battery that you use in electric vehicles, in the battery you have the organic electrolyte that is flammable. So that means our supercapacitor is safer and more sustainable, and most importantly, is also cheaper.
So what are these aspects for your work in GRAPHERGIA?
Well, in Graphehgia, we have, let's say, a different approach. The idea is to avoid using any kind of critical raw material, which is such as graphite for lithium-ion batteries. So the idea is that to go to the cycle of materials, go to the end-life polymers, processing them through laser in order to transform it to graphene. Also, another approach is to use biomass, like lignin or like grape molasses, in order also to transform them into graphene. So think about this, that you take materials that are not useful anymore, and to transform them to materials that are very critical for energy devices, such as batteries and supercapacitors. We can think about how much in the future could make this energy devices industry in Europe, how much independent could be done. Right now, which is completely dependent to Asia or to the United States right now, and think about the footprint of this process if industrialized in the future for the European energy industry. Because in order to be independent in Europe in terms of energy, we have made the route already to increase renewable energy sources. But in order to do this, we have also to increase our capabilities in energy storage. So in order to do this, we have also to make our own energy storage industry. If we go now to compete with the terms of the well-established battery manufacturing industry or supercapacitor manufacturing industry, which is already well-established but out of Europe. So if we go to compete with this, it is more or less sure that we will lose. So we have to bring new technologies in order to catch the train on the next station, as they say. So to be more competitive and to independent.
Yeah, and reducing importing critical raw materials from outside Europe. For example, we can use European biomass-derived sources to make carbons for our supercapacitors. We don't need to import any critical raw materials from outside Europe, and this helps the European in terms of energy storage.
So, yeah, sure.
If I can add something also, because it is also, because you asked also about the taxpayers, what is the impact for them.
exactly.
So new technologies such as graphene or 2D materials or whatever, AI, I don't know, whatever. It's first they bring well, the first thing because it starts with R&D, research and development. So first brings well-paid and high-qualified jobs for the first cycle. This cycle, when all these things are going to industrial deployment, then comes also other jobs like sales or regulations, legal. They have impact in all the value chain of our life, not only the commercial value chain. So new technologies after, let's say, a cycle that lasts for decades, this is true, brings an impact, first economic growth and afterwards social growth. So it is not something like we just spend money to an empty bucket. It's it's money that after a lot of years they bring competence, they bring economic growth and social growth.
So I want to follow up on that because you mentioned workers here, and of course you all, or we are all researchers around this table and do academic research or research in companies. But and you mentioned other potential jobs. But what is your message to young people who want to be a part of the energy transition in Europe? What should they study and how should they think about this?
I think because I teach one course at Chalmers, that is for the battery. What I feel is that the students have the interest in this field already because they know that energy is important, energy storage is important, because not the electric vehicles, that is now is dominated already. I mean, but then we need more batteries. Then they also want to know and also at least to be involved. So I think the publicly, so that means they already get to know about this. Another thing is that once, for example, for us, we have some influence on the student because we teach them, we give the lectures to them, and then we can introduce these new technologies, new materials, new solutions to this energy and to environmental issues. So I think, for example, regarding the graphene, I think graphene, when it's started, is very wonderful materials and many people like it. And then even for the students, they also got to know it from the media and also from other lectures. And then they also want to know what is graphene and how to use graphene to change the world. And then that is our job. That means we can introduce more, we can study more based on the research work, based on the projects, based on the public funding. So I think at least this kind of project is very important. It's not only allow us to develop more, but also to transfer the knowledge from this project to the students.
And maybe also even to younger kids, right? Because the ones who have already come to Chalmers or Tampere or whatever, them we can reach. But how do we reach the 10-year-olds? How do we make them excited about this?
Energy, I think it will be, let's say, the most critical thing of the future, because most of the new technologies that come up, let's say AI, they need a lot of energy, a lot of power. So people should give attention to that. In the matter of science, the matter of engineering, in the matter of management, business development, all the sectors are being affected, and all the sectors will need people in the future, first to learn how to develop new technologies for energy, people to industrialize these technologies, people to develop businesses around these technologies, and also people to learn how to manage this. So it is not only one field, it is something that will affect us in all the aspects of our society.
And I actually think that's a very, very important point to make, right? Because, if you're interested in chemistry, you can be part of the green transition. But you can also be a substantial part of the green transition if you're an electrical engineer and everything in between. And I think that's...
And I also want to add that we need to make more enthusiasm among young generations. What is the application of graphene in energy storage? And for example, I know that a young generation, they want wireless devices. They hate cables and wires and everything. They want everything to be like wireless, and with less effort they charge their phones and so on. For example, one of the application of the supercapacitors is to be integrated into textiles. So imagine that you can have a t-shirt with very thin film of supercapacitors, and at the back side you have some energy harvesting device that you can by wearing that t-shirt and walking on the street, you can at the same time charge your phone.
So what you're saying is basically we should have T-shirts with the Graphene Flagship on the back and a solar cell that powers your supercapacitors that can in turn power your sensors for, whatever we want to measure in the body. Is that what we should take from this?
Exactly.
Or, for example, IoT, Internet of Things devices. So we're going to have millions or billions of sensors in the future, and they are going to connect with each other wireless, and we need to power them. And supercapacitors integrated with energy harvesting, solar cells, they are very, very promising devices to power those IoT things.
And think about that if we develop all these things, then we will create tons of data that will need even more power to manage them.
Or even AI. Every question that you ask from ChatGPT or Copilot or other AI tools, they need energy to answer to that question. So you can see how much energy we need.
It takes a lot of energy, actually. That is true. So I think that we should start to sum up this. So I'm going to give you all the chance to say a few words as your ending statement here. Do you want to start, Hamid?
Yeah. As the last comment from my side, I would like to invite interested youngsters to come to the energy storage field to start their bachelor degree and also continue their studies in master's and PhD, because I think there is a lot of efforts we need to make in the field of energy storage, and daily we have a lot of energy from sun, so we need to harvest that energy and store it in somewhere, and supercapacitors are the best devices to do that. Thank you.
Masouras, please.
So first of all, thank you for hosting this very nice discussion about energy and graphene. So from our side, I will continue more or less to encourage people to first see what we are doing in our projects, in initiatives like Graphene Flagship, to start connecting the dots between from material to application, to the end user, to business development. There are a lot of aspects that comes the one after the other, and to to understand and to be involved in this industry more actively, more with more understanding sometimes that we're not doing things just to do them. We're doing things because we believe that energy is one of the sectors that Europe have to really give emphasis the next years.
Jinhua.
Yeah, as I introduced at the beginning, I have been working on graphene for many years. Since my master, it has been more than maybe 15 years. So actually for myself, I believe in this material, the graphene. I still think that this material can change the world. And as we demonstrated in different projects, this have a very important role to change something. And another way is that for the younger generation, I think this is also a new field, and then this can create new jobs, and then this can give you a better future. So I think this material is very important, and when we use it in energy field, it's also very important because for example, in our project, we use it for supercapacitor, but in batteries and others, it can play a role. Yeah.
Great. Thank you so much, all of you.
Thanks
I
for
feel like
inviting us for this
we
podcast.
could have gone on for another hour, but unfortunately we don't have that time. And I also have to figure out how we should make this t-shirt a reality. Thank you.
Thank
Good
you.
point. Thank you very much.